So we've got an arrow that's going to hit a target, and the arrow is going to embed itself into the target, and we're going to be able to measure the depth at which the arrow goes in. So a mass of our arrow is 50 grams. It's going to penetrate this tree to 10 centimeters. And because we're doing this in a scientific way, we could actually measure the force that was applied. So we actually had a force of 4,000 newtons. We want to know the initial velocity that the arrow has when it comes in to the tree. We want to know what is the velocity that the arrow hits. So we're going to use, in this one, we're going to use the work energy theorem. And that says that my work, the work done, is going to equal the change in the kinetic energy of my system. Now I can look at it as the change in kinetic energy, as the potential energy, but one of the things about this particular problem is the change in potential energy is equal to 0, because the height that the arrow comes into the target, and as the arrow stays in the target, I'm not changing my height at all, so there's no change in potential energy, so I don't have to worry about that. So the work done is the force times my distance times my cosine of my angle. But in this case, the cosine of the angle is equal to 1, so I don't have to worry about that because I'm directly in line. I'm getting the best bang for my buck, and I'm good there. And that's going to equal 1/2 the mass of my arrow, velocity final squared minus velocity initial squared. This is what we're trying to find. All right, that's what we're trying to find. We know what the velocity final is because when the arrow comes to a stop, that says my velocity final is equal to 0. And we're going to get this negative here because that is the velocity that's going to give us a direction, and it tells us that the velocity is in the opposite direction of the force being applied. So we can infer what we've got there. So basically now I have the force times my distance is equal to 1/2 m, and I've got a negative, velocity initial squared. And that's really what we're trying to find. So now I'm going to get 2 times my force times my distance divided by the mass is going to equal the initial velocity squared. And because that's going opposite, I need to make sure I got negatives, because we're doing a square root of a positive is not going to, or a negative is not going to help me out. And we can infer these directions there. So we're okay there. So now I'm going to have my 2 times my force times my distance divided by the mass is going to equal the square root of 2 times, we said 4,000 newtons. The distance that we're dealing with is times 0.1 meters, and we're dividing it by the mass of 0.05 kilograms. Because I have to make sure all my units pan out. So my Newton is a kilogram meter per second squared. I'm multiplying by meters. I'm dividing by kilograms. Kilograms cancel. I got meters squared over second squared. So I'm going to end up in meters per second, which is exactly what I want to do. And so now I got to just plug it into the calculator. And this says it was traveling at 126 meters per second. And we don't necessarily have a good feel for that, but if it were a bullet, that would be totally acceptable. So that is likely to be okay. But this is going back and using the work energy theorem in order to calculate a value. We're going to do another one kind of like that one. So I've got a roller coaster here. We're going to start up with my roller coaster. It's going to come up here. It's going to go here, and then it's going to go off into a straight line. Okay. And we're told that we're giving ourselves some information here. This is going to be 140 meters. This height here is going to be 95 meters. This height here is going to be 80 meters. We're going to start at the top. We're going to get some information here. We're going to come off of it here, and we're going to come to a stop here. And we're told that this distance is 120 meters. So we're going to start with an initial velocity of 0. We're going to use that the mass of my car is 850 kilograms. We want to know the velocity at this point, and we want to know the force applied to stop the car. All right. Okay, so we're going to use, for part 1, we're going to find the velocity. And we know we're going to use conservation of energy. And this is going to allow us to have the total energy at the top has to equal the total energy, and we're going to give this a point. We're going to call this point B. But now my point B isn't just, my point B has got kinetic energy associated with it, and it has potential energy associated with it. So I got to worry about that now. I got to worry about each one of those. But this one is just going to be mgh. Well, my kinetic energy at point B is going to be 1/2 mvb squared plus mgh at B. And this is h at A. We're going to call this point A just so we can keep that. Well, the good news is I don't have to work with my mass in here. So what I'm going to get is I'm going to get GHA minus HB is equal to V squared B over 2. So I can move my 2 over here. So I get 2G, and I can look at the height difference. And that's going to give me my VB squared. So we can go ahead and do that. So I get 2 times 9.81. This is 140 meters. This is 95 meters. And that's going to give me my VB squared. That says it's going to be 883 is equal to VB squared. Take the square root of that. And we're going to end up with 27.7 meters per second is the velocity at B. Now we're going to do the next thing here and look at our stopping distance. And so for part 2, we have to use the work energy theorem. Here, we're going to still have the total energy at the top. But now we're going to get the kinetic energy as we go into our stop. We're going to have our potential energy. Then we're going to have the work done, which is going to be my force times my distance times the cosine of my angle. But my angle is going to equal 1, so that's all good. But my kinetic energy at this one, when we're going there, that's going to equal 0. So we're going to end up doing the exact same thing that we've done here. So I'm going to end up with 2G HA minus HC is going to equal the negative force that's applied times my distance. No, that's not a 2. I have to have my mass in here at this point. Sorry. mg, there we go. Because the 2 comes from that, and so we've got that part there. We're solving for force, so I'm going to get mg HA minus HC divided by my distance is going to equal the force that has to be applied. So now I'm going to have the mass, which was 850 kilograms. My initial height was 140. My new height is 80. The distance is 120. And then I have a 9.81 that I've got to add in there. And I'm going to end up with 4170 newtons. And that's negative because it's the applied force that the brakes have to apply. So it gives you a little bit of a different problem to work with. All right. Gave you a bunch of problems to look at. Gave you a variety of things there. Are there any questions?